My name is Rose Hartman. I use she, her pronouns, and I am on the Arcus education team in DBHI. And today's talk is about missing values in R. I want to mention if you're following along with the slides, you can type S to see the speaker notes show up on your screen. And I make obsessively complete speaker notes. So that'll be a valuable resource for you if you want to go back and read through the things that I'm saying during the talk as well. So just a few announcements before we really get started here. For anyone here today that isn't already part of the CHOP R user group, I strongly encourage you to join, and it's open to Penn folks as well. The CHOP R user group has more than 500 members from all departments. This is a great place to network with other R users, get help with coding problems, and learn about new packages, webinars, and conferences. We also have semi-regular meetings and workshops like this one. And we have regular office hours appointments available to get help with R. So we've set up a calendar online where you can book an appointment. And if you are actually an R expert yourself and you're interested in offering appointments, get in touch with me because we're always looking for more people to offer appointments as well. And today's talk is just the first in a new series that we're calling R102, Mastering the Fundamentals. These workshops are intended as a continuation of the popular Intro to R for Clinical Data workshop that we offer a few times a year. We're designing these talks with beginners in mind, so if you're trying to figure out how to get started with R or how to start applying it in your own work, these talks are for you. To see the schedule of talks, check out the website for the series, and we'll also post links to the slides and recordings there as well when they become available. The next talk will be on April 8th, Summary Statistics in R, and that will be Alexis leading that one. Okay, great. So today is a quick dip into what you might call some 102 level R. In other words, if you've had a little exposure to R before, such as through an Intro to R for Clinical Data workshop or something else, then this is hopefully the right level for you now. If you're completely brand new to R, first of all, welcome. But you may find it a little tricky to actively follow along with the code today, since I am going to skim over some of the initial steps. But go ahead and give it a try, or just listen and watch if that feels like more the right speed. Our topic today is missing values in R, one of the major stumbling blocks folks typically encounter when they start trying to use R to analyze data in the wild. Real data are messy, and missingness is one of the main kinds of mess you'll have to deal with. If you do have any questions that come up during the talk, please feel free to put those in the chat. We have several very friendly R experts on the call today helping out, so they may be able to chime in and answer your questions, otherwise I can. So what we're going to be covering today. I'm going to talk about how to check the number and location of missing values in a data frame, how to mark values as missing, how to use common arguments like NARM and NAAction to control how functions handle missingness, and how to remove cases with missing values from a data frame. I am not going to be teaching statistical remedies for missingness, like multiple imputation. That's not part of today's talk, but do ask me about that later if you're curious. I'd love to talk about things. That's just not the plan for today. So, why would you want to check for missingness? Checking for missing values can help you to check whether the data were read in correctly. In many cases, you actually know beforehand whether or not there should be any missing values on particular variables in your data because you know about how the data were collected. So after you import the data into R, checking for missingness can give you a sense for whether the data were imported correctly. For example, if you were expecting some missingness on a variable and you see none, that can give you a hint that the missing values in the raw data aren't being correctly interpreted by R. Missingness will also impact your effective sample size. So when you have missing values, the sample size that you can actually use for your analysis is often reduced. For example, if you collect 100 samples, but 20 of them are missing on at least some measurements, then you might have only 80 complete samples that you can analyze. And lastly, if your analysis will involve fixing missingness statistically, the first step is always describing the missingness. If you have substantial missingness in your data, and a good rule of thumb here is if about 5% or more of your data are missing, that would be considered substantial. Then you may need special statistical techniques to be able to analyze the data without introducing bias. And as I said, such techniques are outside the scope of this talk, unfortunately, but there are lots of excellent papers on this and tutorials available with instructions. So I've got a few of these learn more slides thrown in throughout the presentation. They include links to resources I like for learning more about the topics that we're covering. I won't click through to any of these resources right now, but you have access to the slides, so feel free to go back and review those links later if you like. The link here is to one of my very favorite academic papers, Rubin 1976. Definitely worth a read. So what does missing look like in R? Different statistical software mark missing values in different ways. In R, missing values are marked with NA, which is short for not available. Technically, there are actually 4 additional kinds of NA corresponding to different data types. For most practical purposes, though, you don't need to know anything about these different kinds of NA. They all just mean missing, and you can usually just use NA to refer to all of them. For example, here's a small table of made-up data. Note that the second and the third rows have NA instead of numerical values for some of the measurements. The NA indicates a lack of information for each of those cells. Those values are missing. Now, if you've been using R for a little while, you may have seen null or NaN in some cases instead of NA. Null and NaN work a lot like NA, but they're also a bit different. They don't stand in for missing data the way NA does. Instead, null shows up when you have an expression or a function whose result is undefined. For example, a logical comparison whose result is neither true nor false. And NaN, which is short for not a number, shows up when a calculation produces something other than a number, like if you try to take the square root of -1. So one way to see missing data in R is to take a look at the full data set, either by printing it in the console or using View to see it opened like a spreadsheet. Then you can just scan visually for NA cells, as in the example table in the previous section. If your data set is anything larger than a handful of rows and columns, though, you'll want a way to summarize that information without having to count everything by hand yourself. There are many functions available to check for missing values in R, but one especially handy one is the summary function. It gives you some basic summary information about each variable in your data, like minimum and maximum values, and it will also tell you how many missing values you have for each variable. Because it gives you summary statistics and missingness information at the same time, many people like to use it as a quick way to check their data as a start to their exploratory data analysis. And there are also many more options for exploring your missing data. I like the VisDat and Amelia packages in particular, but there are more. I think summary is a great place to start, though, so that's what we'll focus on today. Okay, so enough preamble. It's time to actually start coding. So by far the best way to learn R is to practice. So do work through this code yourself as you follow along. You have 2 options for doing that. The first link will take you to Posit Cloud, which gives you a way to work with the code right in your browser without having to install anything on your machine. You will need to create a free account if you don't already have one. So I'm going to go ahead and click that link now. And I'm going to log in with a different account than the one I used to create this project so that you can see what it'll look like from your end. It takes a little while to load. And I want to draw your attention to this red sign at the top that says temporary copy. That's because when you pull this up, it'll initially be working in sort of a read-only copy of the project I made, which is fine. But if you'd like to be able to take notes and make changes and try things out in the code and then save them, you'll need to click Save a Permanent Copy to give yourself your own version to work with. And it's just taking a moment to load here, but I think this should be fine. You can also get all of the code for this talk directly from our GitHub repository and download it to work on your own machine if you have R and RStudio installed. If you want to go that route, then you go to our GitHub repo, which is the second link here, and I'm going to go ahead and click that now. This has all of the files for this series. And you'll see there's a green code button. If you click that, the last option is download zip. If you click that download zip option, that'll start downloading a zip file for you that has everything from this repository. Once it's done downloading, you can double click that to unzip the file and you'll have everything you need. If you're comfortable using Git, you can also clone the repo or fork it if you'd like a personal copy. And if you don't know what cloning and forking are, no worries, just use the zip file or the POSIT cloud instance. And the first thing that we'll do today in our R code will be to load the tidyverse packages, since we'll be using several functions that come in the tidyverse, as well as a built-in dataset that comes with tidyverse. So I have a link here to the tidyverse website, which has tons of great resources and tutorials. And I also want to pause here for a moment to invite anyone that's having trouble getting access to the code, either with that POSIT cloud link or by downloading the files, to let us know in the chat. As I said, we've got a couple very friendly R experts on the call, so one of them can help you troubleshoot. If you've got the code pulled up and ready to go, please thumbs up the comment that I'm putting in here. So if you could do a thumbs up on that comment here to let me know that you're ready to move on, that would be wonderful. Great, I see some thumbs ups coming in already. Yes, great question. So there won't be any code pulled up to begin with. So it should look something like this probably, where you have the console with nothing, no code ready, and then you have some files down here. So that's expected behavior. So we'll go ahead and start working here. If you are working on your own computer, rather than in the cloud instance we set up, then you may need to run install.packages first if you haven't ever used the tidyverse packages before. If you're working in our POSIT instance, then this has already been done for you. And either way, on your computer or in the cloud, you will need to run this library command. So the library command here is written out for you in the first chunk of the file missing_values_exercises.rmd from the exercises directory. And I'll go ahead and open that file up now as well so you can see where it is. So here's the file pane in the bottom right. There's a folder called exercises. So I'm going to click that to open the exercises folder. And you should see a file called missingvaluesexercises.rmd. If you click that, it should open in your script window in the top left. And the first code chunk there is library of tidyverse. So I'm going to hit the green play button there to run that code. And you should see a message like this. And I do want to point out, when you load the tidyverse, it prints a lot of material here, and some of it is in red, which makes it look like these might be errors, but this is actually all expected behavior. It's just letting us know what packages it installed, and then it's reporting that there are some conflicts where functions we've loaded from tidyverse will mask functions in base R, but that's expected behavior, so that's all good there. Okay. So we'll go ahead and jump in and start looking at the data. The data frame that we're going to use today is called msleep. And so either in the console or in that exercises RMD file, run the command head of msleep. And if you're in the exercises file and you just scroll down a little bit, you'll see that that command has been written out for you there. So you can just click the green play button to run that code. So you should see something that looks a little bit like this, showing the first 6 rows of that msleep data frame. And now this is one of the example data sets that comes built in when you install the tidyverse package. So it's already available to you without you having to read it in or download anything. And for those of you that have worked in R before, you know that importing data is like a whole thing. So we're definitely skipping over a potentially tricky bit by using built-in data. but we only have so much time today, and I really want to be able to focus on the missing values as much as possible. So we're just merrily skipping past all of the importing and tidying that would normally happen. And for built-in data sets, they have help documentation that you can pull up, just like you can pull up help documentation for functions. So you can learn more about this data set by running the command !msleep. And that code is here for you as well. And you'll see help documentation come up in the bottom right pane of your RStudio window. It tells you tons of information about the data set. Briefly, this is a data set of a bunch of different mammals, including information about how many hours they sleep, their body size, brain weight, and a couple other things. So let's go ahead and run the summary function now to see how many missing values we have for each of the variables in this data frame. And if you run summary of msleep, you should see something like the following. The first thing I want you to notice here is that R is actually giving us different information for each variable, depending on whether it's a character or a numeric variable. So the first few variables in this data set are character variables, and R won't try to print things like the minimum and the maximum for characters because it doesn't make sense to try to find the minimum of text. But if you look at the later variables, starting with sleep total, you'll see that R does print minimum, first quartile, median, mean, third quartile, and max for each one. And I want you to particularly look at the bottom row of the summary statistics for sleep REM, sleep cycle, and brain weight. You're seeing the count of NA values for each variable. The other numeric variables, sleep total, sleep awake, and body weight, don't show anything for the NA count, which means they have no missing values. And now we can get more better information about those character variables by turning them into factors, but I'm going to skip that for today because just in the interest of time, we won't need those to be factors for anything else that we're doing in our exercises today. So I'm going to skip those now, but you do have access to the slides. So if you want to look at that code later, you can. So we'll just zip through. Okay. And next, we'll talk about how to filter the missing values. But I want to start with a quick refresher on what the filter function actually does. So filter selects just the rows from a data frame that return true for the logical test you put in. For example, if we look at the command filter of msleep vor == karna, that will take the msleep data frame and it will check each row to see whether vor equals karna in that row. Rows where that's true will be included in the output, and any rows where that's false will get dropped. So here's what the result of that command looks like. And I apologize, I'm getting some sort of awkward text wrapping on the slides here. But if you look down the vor column, you can see karna, 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 all the way down, because any rows where it was not karna have been removed from this data set now with that filter command. One tricky little thing that I want to be sure to draw your attention to is the equals test. In R, if you want to test whether two things are equal to each other, you have to use equals equals. Just a single equals is a setter used for assigning values, not testing whether two things are the same. And here are a few of the logical tests that you might use in R in a command like filter. This isn't all of them, but these are just some popular ones. Less than, greater than, and then equal to, which is that equals equals, and not equal to, which is exclamation point equals. And I know we went through that very quickly, but here's a link if you want to come back to review more information about filter later. All right, so how might we write a command to filter for missing values? Well, a reasonable attempt would be filter of msleep, and then if we wanted all the rows that were missing for the brain weight variable, we would do brain weight == NA. But that actually doesn't work. In fact, if you're following along in RStudio, You may even have noticed a little yellow warning triangle appear to the left side of your screen next to the line number with that code. And if you hover your mouse over the warning sign, you'll see a message that says, use is NA to check whether an expression evaluates to NA. That's because this is a very common mistake. Most people try equals equals NA and exclamation point equals NA to test whether something is or isn't missing, respectively, before they realize R won't allow that. So let's try that again. And instead, to test whether something is missing, we have to use the is.na function. You can negate this function with an exclamation point. So exclamation point is.na tests whether something is not missing. So let's try again to filter the data to show just the rows where we have missing values for brain weight. And our command here will be filter of msleep and then is.na of brain weight. And this time you can see it is printing every row from the msleep data frame that has just missing values for brain weight. Real quick before I jump past this, there's an excellent question from Samantha in the chat. After filtering, is the filtered data set saved as a new data frame, or does this update the current data frame? And the answer is, in a command like we're looking at here, filter of msleep is NA brain weight, it's not saving anything. It's just going to return those, whatever you've asked for there. So in this case, the filtered data set, it will print it out, but it's not saving it. It does not change the underlying msleep data frame, and it's also not creating a new data frame. So if you do want to save it, then you have to explicitly include that in your command. We'll look at a couple of examples of that later as well. But that's a great question, Samantha. Okay, so that brings us to our first coding challenge. So go ahead and open up that missing values exercises file if you don't have it open already, and scroll down until you see coding challenge 1. We'll work on this for just a couple of minutes, and if you don't finish during that time, no sweat, just pause wherever you are, and then we'll take a look at the solutions together. I'm going to put a little comment in the chat now, and when you're finished working on the coding challenge, thumbs up that comment for me to let me know that you're ready to move on. I also want to create another opportunity here for anyone that's having trouble getting access to the files or having trouble loading the Posit Cloud project to drop a note in the chat so we can help. And we'll just take a couple minutes to work on this and then talk through the solution together. Okay, great. I can see a bunch of thumbs ups coming in through the chat there. So let's go ahead and look at the solution for this together. So here's my Posit Cloud instance. I'm going to scroll down until I get to that coding challenge 1. Okay. So it says, now fill in the partial code below to filter the data to look at the rows that are not missing for brain weight. And the command is partially written for us. So it's going to be a filter command like we were just looking at on the msleep data frame. And the bit that's missing is the logical test that will describe the rows that we want included here. And so we want things that are not missing for brain weight. So that will be exclamation point is.na of brain weight. Okay, I'll go ahead and try running that. Beautiful. And I'm going to scroll over here so that I can see the brain weight column. And yeah, as I'm looking down, I don't see any missing values there. So that looks like that ran just fine. Okay, so you may need to assign values to NA as part of your data cleaning sometimes. When you're working with data, as part of the data exploration, you may notice values for some variables that you know are impossible or extremely unlikely. For example, imagine that you have a data set called DF with a variable called rating. You know that it's on a scale from 1 to 5, so respondents weren't able to rate it as anything outside of those options. And yet, when you read in the data, you see there are a handful of -99 scores for this variable. Depending on the data collection mechanism, these may be the result of typos during data entry, or it could be a systematic way of marking invalid or missing responses. Either way, you don't want to treat those negative 99 scores as actual responses to the question. Imagine how they would distort the estimate of the mean for that variable. Instead, you can mark them as missing so that they can then be excluded from the analysis. So here's some code to assign the negative 99 values in our pretend dataset to missing. And this is kind of a lot, so let's break that down. We're using a mutate command to change or mutate a variable, a column of data. And we're setting what the new value of this column should be by using a special conditional function, the if-else function. The if-else command is what's called a ternary operator, and it has three parts: a conditional test, a value to use if the test returns true, and a value to use if the test returns false. Our if-else statement begins with a conditional test, in this case, rating equals negative 99. For each value in rating, it will run that test and return either true or false. If it returns true, then it assigns the next argument, in this case, NA, which will mark that value as missing. If it returns false, then it assigns the last argument, which in this case is just rating, so it would leave the value untouched. So for any rating values that equal negative 99, we're asking it to replace them with NA, otherwise to leave them as they were. And that brings us to our second coding challenge. So go ahead and look back in that missing values exercises file, and we'll just take a couple minutes to work on this one as well. Okay, so let's go ahead and take a look at this together. So I'll go back to my RStudio here and scroll down to coding challenge 2. It says, let's pretend you know that these data were only recorded over an 18-hour period, so it would have been impossible to have a total sleep time of greater than 18. And yet, when we look at the data, we see there are a few animals with sleep total over 18. So there's a little code here that was just written for you, including summary of msleep $sleep total. So that's that same summary function we were using before, but this time instead of running it on the whole data frame, it's just going to run it on that sleep total variable. So I'll click the green triangle here to run. So we have a minimum sleep total of 1.9 hours, an average of 10.43, and I can see the max is 19.9, so that is over 18. So there's at least one animal with a sleep total that's over the possible amount. And then this filter command here will filter the msleep data frame, and the criterion that it's using is sleep total over 18. So this will show us every row from the msleep data frame where sleep total is over 18. And if I run that, I can see there are 4 animals here that have sleep total values that are above 18. And now in our pretend scenario, because we know this was only recorded over 18 hours, those must be typos or some other kind of error. So we would want to exclude those values from the analysis. So then the challenge bit is to fill in this code to mark values for sleep total that are over 18 as missing. Oh, and there is a solutions file as well. So back to the files pane, I'm in the exercises folder right now, but if I click back to the project folder, you'll see there's a solutions folder as well. So that has solutions files in there for all of this too. But I encourage you to work on it yourself because that'll be much better practice. Okay, so for this command, we are going to overwrite the msleep data frame. So we're saving new content onto that value there. So we're going to overwrite the msleep data frame, and we're going to overwrite it with this mutate command. It'll be mutate of the msleep data frame, and the column that we want to change or to mutate is sleep total. The way that we want to change it is with this if-else command. So the first argument of if-else should be a logical test. And in this case, it will be sleep total greater than 18 because those are the rows we want to change. And now, if sleep total is greater than 18, what value do we want sleep total to have? Well, we want it to be missing, so that'll be NA. And then the last argument is what we want it to be if sleep total greater than 18 is false. So that's all of the other rows. Oopsies. And in that case, we actually don't want to change the values at all. We just want to leave them what they were. So that would be sleep underscore total. So let's go ahead and run that. And so running that code doesn't produce any output here, but you may have noticed it's putting something in our environment. So we have our own version of the msleep data frame now that we've been editing. And to check that it worked, we can take a look again at the summary of the msleep total, sleep total column. So if I run this command, now you can see the max is 18. So it's not, there aren't any values now above 18. And we have 4 NAs, which we didn't have before. So those are those 4 animals that had sleep totals over 18 before, and now they've been replaced with missing data. And I have some links here for some more work on mutate and if else. And I also do want to mention, and I'm not going to get into the weeds with this, but for anyone that's curious, there are 2 different but very similar functions called if else and if underscore else. And although they are often interchangeable, this code is actually one of the few times where they do work differently. So if you're curious, come back and look at this slide later. If not, don't bother. All right, so a note about removing outliers. These are all some perfectly reasonable situations in which you should mark values as missing. If you have extremely unlikely outliers, values that you know are logically impossible, like what we just saw in the previous example, or if you have values that you know are meant to mark missing or invalid responses. Those are all really great reasons to mark values as missing in your data. Note, however, that you should be cautious in general when excluding observations, especially if you're potentially excluding observations that might be valid data. And I've got a great link here for you to learn more about how removing outliers is something that can introduce bias into your results. All right, so most real data sets do have some missing values, and it's likely that you'll still want to be able to generate plots, run statistical analyses, etc. on those data. So how to work around the missing values is an important question. In general, there are 2 basic options for how functions in R can handle missingness. The first is that the function can just skip over the missing stuff and run the calculations on whatever data are available. This is sometimes called listwise deletion or complete case analysis. And then the second option is that the function can stop everything and throw an error if there are missing values in the calculations. As you move to more complex functions, though, the options for handling missingness can become more complex as well. Today, we'll talk through several R functions with different kinds of options for handling missingness. In particular, we'll talk about the following functions. Mean, which calculates the mean or average of a set of numbers. PRComp, which runs a principal components analysis, or PCA. GeomPoint from the ggplot2 data visualization package, which is used to create scatter plots. And Core, which is used to generate a correlation matrix. And I want to pause here to say that you do not need to understand the underlying statistics for any of these functions to be able to work through the R code and learn from the missingness examples. So if you haven't made a correlation matrix before, or you've never even heard of principal components analysis, no worries. That's probably the case for most of the folks here today. So know that you're in good company. We're not going to talk about what these tests are for or what they mean. We're just using them as examples to see different ways of handling missing values. If you do want to learn more about these functions and what they do, you can click through the links in the slide before for explanations and tutorials. Okay, so first we'll look at the argument NARM, which is available in many functions in R, including the mean function. We'll start by pulling up the help documentation for mean by running $mean in the console or searching for it in the help pane. I'm going to show you what I mean here in Posit Cloud. So in the console, if I write MEAN and then hit enter, that will pull up the help documentation for mean for me, or at least it should. There we go. And you can also just search in the search bar here in the help pane. So if you look Through that, under arguments, you'll see that one of the arguments is NARM, and the description for that argument is a logical value indicating whether NA values should be stripped before the computation proceeds. In other words, do you want to exclude missing observations and just do the calculation based on the available data? The default value is NARM equals false, which means no, don't exclude missing values. So let's try that with the brain weight variable from our mSleep data. And now remember that brain weight is one of the ones that does have some missing values. And we won't specify anything for the NARM argument initially, which means it'll just use its default setting, which we know from the help documentation is NARM equals false. So if you run mean of mSleep $brain weight, you get NA. So there are some missing values for brain weight. So right now, R is trying to take the mean of several numbers and a handful of NAs. There's no way to get an average for something that's not there, so the result is NA, not available. Let's try modifying that code to change the behavior to NARM equals true. So we'll run that same command, but add the argument NARM equals true. Now we get a value. That's the average of just the available data, ignoring the missing ones. You'll see NARM as an argument for many functions in R, usually with the default set to false, as it is for mean. For more complex statistical functions, there's often an NA action argument instead of NARM. We'll start with the function PRComp, which is used to run a principal components analysis, or PCA. And for the purposes of this example, it's perfectly fine if you haven't run a PCA before, or even if you've never heard of it. We'll just be using it as an example to explore how R handles missing values in statistical analyses. Like many functions, PRComp has an argument called NAAction, which controls what happens when the function encounters missing values. The possible options are usually NAFail, NAOmit, and NAExclude. So if we pull up the help documentation for PRComp, and you look under arguments, you'll see the description for NAAction is a function which indicates what should happen when the data contain NAs. The default is set by the NAAction setting of options, and is NAFail if that is unset. The factory fresh default is NAOmit. So we can see from the help documentation that unless you've changed some of your settings in R, the default option for NAAction will be NAOmit. The NAAction argument is computationally a bit more complicated than NARM, which can just be true or false, but actually they work kind of similarly. The NAFail option for NAAction is a lot like using NARM equals false. When you have an NAAction equals NAFail, you'll get an error when you try to run the function on data with missingness. The NAOmit and NAExclude options both work a lot like NARM equals true. They'll skip over missing values and run the function just on whatever data are available. The difference between NAOmit and NAExclude is pretty subtle, and in my experience, it only really matters if you're going to be using the resulting model objects in kind of advanced ways. So one big difference between NARM and NAAction is that while NARM equals false is usually the default, for NAAction, it's usually NAOmit, which means that the function will remove missing values. So if we run PRComp without specifying anything for NAAction, it'll just use that default behavior. And here's the output of that command. Like I said, we're not actually talking about these functions as statistical tests, so we'll just skip right past all the standard deviations and the rotations and what have you. But one important thing I want you to notice here is that nothing in this output tells you that PRComp excluded rows with missing values from the analysis. That's how many functions in R work, and it's one reason why it's important to look at the help documentation for functions you're using, so you can see what the function's default behavior for handling missingness is. Without checking the help documentation, you might wrongly think that this PCA output was based on all of your observations, not just the complete cases. So let's run that prcomp command again, but we'll add an argument this time with NA action equals NA fail instead. So when you run this code, you should see an error that includes the message missing values in object. Some people prefer to use NA fail for most functions because they want to see an error message whenever they have missing values rather than R just silently dropping them. So I said that a lot of functions won't tell you when they're dropping values, but some R functions do show a warning when they remove missing cases with missing values. For example, let's use the ggplot package to create a scatter plot of body weight and brain weight with the geom_point command. If we run this code, it produces the scatter plot that we asked for, but you'll also see a warning saying removed 27 rows containing missing values, geom_point. That's to remind you that it's ignoring any observations that are missing for either of the two variables we're plotting. Note that if you're running this in the RMD document, that warning will appear above the plot in the R console box, just below the code chunk, rather than on the plot itself. And if you run the ggplot code in the console, instead of running it as a chunk in the RMD document, then the plot itself appears in the plots pane, and the warning will print in the console. And now, in the interest of time, I'm going to skip over this last example here with correlations because it's much less broadly applicable than the others that we've talked about. But I left the slides in here so you can go back to review that yourself if you're curious. All right, so now we're going to jump into some quick quiz questions to check your understanding. Give me a thumbs up reaction in Teams if you think this is true and thumbs down if you think it's false. The output from R functions usually tells you how missing data were handled. Thumbs up for true, thumbs down for false. There is no thumbs down, sorry. Oh yeah, I forgot about that. There used to be a thumbs down option. So never mind on that, I guess. My apologies. So it should be thumbs down here. The correct answer is false. So although some functions like geom_point do provide a warning when they drop missing values, many functions in R do not. And we saw an example of this with the prcomp function. So that should be false. Okay, and if you want R to skip over missing values and give you the results based only on the available data, which argument might you use? And maybe go ahead oh, that's a good idea. I'll put it in the chat. So you can thumbs up and thumbs down this in the chat. Oh, never mind. That's going to be huge text. So NARM equals true or NARM equals false for skipping values. We'll just take a moment to think quietly and then we'll talk. Thank you, Elizabeth. And yes, I can see folks are thumbs upping that, and it should be NARM equals true. So for functions that have an NARM argument, like mean, then setting NARM equals true, so NA remove, you can think of that, will give you the result ignoring the missing values. And the default setting for most of these functions is NARM equals false, which will return NA as the result whenever there are missing values present. All right, so sometimes you will want to create a new version of your data that excludes cases with missing values. This can be especially important if you want to make sure that you're using a consistent data set across several related analyses. For example, let's say you ran a study on the relationship between cortisol levels and time spent on a challenging task. In addition to measuring cortisol and how long participants spent on the task, you also maybe collected a set of demographic variables and background information like age, education level, etc. And because the main focus of your analysis is on cortisol, you would want to exclude any participants who have missing cortisol values, maybe because of problems with the saliva sample they provided. even from parts of the analysis that don't use the cortisol data directly. For example, you may begin your analysis by describing your participants with summary statistics on their demographic information, like what's the median age in this sample. If some of those participants have missing cortisol values, you would want them excluded from the demographic summaries as well. The most straightforward way to do this is to save a new version of your data that only includes the observations that you want in your final analysis, and to use that for all of your calculations. So there are a few different options for removing rows with missing values in R. One is NA omit. And then another is to use a filter command with isNA, like we talked about a little bit before. So if you want a version of your data with no missing values in it at all, you can use NA omit to remove any rows with missing values. Importantly, NA omit will remove rows with missing values on any variable. So to illustrate, let's save a new version of our data frame called msleep_no_missing, which will have all of the observations with missing values removed. So if we run this code, that'll save a new data frame for us called msleep_no_missing. And then we can check to see how many rows were in the original data. So if you run the command nrow, which returns the number of rows of msleep, that gives you 83. So there are 83 rows in the original data. If you run nrow of msleep_no_missing, the result is 20. So there are only 20 rows left because we removed anything that wasn't a complete case there. You may prefer to just pick which variables you want complete data for and only remove rows that have missing values on those key variables, potentially leaving rows that are missing on other variables. If we want to create a version of the data that doesn't have any missing values for brain weight, let's say, but allows missing values for other variables, we can do that with filter. So here's a command, and this gets at your question from earlier, Samantha, where we are running a filter command and we're going to save it as a new data frame. We'll save it as the data frame msleep_no_missing_brainweight. And the filter command will be msleep !isNA brainweight. That'll save a new version of the data set with skipping all the rows that have missing values for brain weight. Okay, so for our last little challenge here, I'd like you to consider the following code and decide if you think this code will run without an error. Take your time with this one. I'll give you a couple of minutes to think through it, and then we'll discuss. And here's a tip. If you want, you can try running this code yourself if you want to test it in, excuse me, in RStudio or Posit Cloud. You can type out this code and run it to check what happens. So we'll take a couple minutes to work on this. All right, so let's come back together. We'll talk through this. If you're still working through it, no worries. We'll talk about it together. And this was a tricky one. So we've got two main pieces to the code here. The first piece saves a data frame called model_data. And then the second piece runs the lm function. If you've never used lm before, I hope you didn't let that trip you up. Even if you have no idea what the lm function is doing, you can notice that it has an NA action argument, just like we looked at for PR comp. So if we look first at the bit with lm, lines 5 through 7, it looks like lm is doing something with the sleep total and brain weight variables. And it says data equals model_data. So that suggests that it's working with that data frame. And then we see that it has NA action equals NA fail. That means the function should throw an error and not run if there are missing values present. When we tried that with PR comp, we did get an error right away because there were missing values in the data. So are there missing values in the data here? To answer that, let's look back at the first bit of code. It starts with the msleep data frame and it puts it through a couple steps with pipes. Excuse me. The first step is the select function. And we haven't really talked about that much today, but select takes a data frame and pulls out just the columns that you list, dropping any others. So here it will take the sleep data frame and then just keep the sleep total and brain weight columns. Then there's another pipe sending that 2-column data frame to the NA omit function. And now, even if you don't know what select is doing, we know that NA omit will remove any rows that have missingness on any variable. So in this case, what will happen is the NA omit function will get a 2-column data frame that just has sleep total and brain weight, and it will remove any observations that have missing values on either of those. So the resulting data frame will be just the column sleep total and brain weight with no missing observations. So there will be no missing values at all in that model data frame. If there were missing values, we would expect the LM function to throw an error, since it has NA action equals NA fail. But here we know that there will be no missing values at all, so this should run with no errors. And indeed, if you run that code, it does run without errors. That's running a linear regression, in case you are curious about LM. Okay, so what we covered today. We talked about using summary to quickly check a data frame for missing values. We talked about filtering using is.na to test for missingness. We talked about assigning values to NA using if-else, the NA-RM argument, and the NA action argument. And we talked about using NA omit to remove all rows with missingness. And we also did a bunch of extras throughout on data transformations and data cleaning. So that is a lot. Don't expect to remember everything. You have the slides and you have the example code to go back to. So my goal for you today is to come away with a general impression of how to work with missing values in R and to be forewarned about some of the gotchas you might encounter. So I have some additional resources listed for you here. These are all excellent resources that cover a lot of the same content we talked about today, but from a different perspective. So you may find that helpful to consolidate your learning. And I have a practice opportunity for you because this same content is available as an interactive tutorial online as part of the DART program. So Elizabeth just put a link for that in the chat if you want to work through the content that way. And that's it. We have just 1 minute, I'm afraid, for questions, but do let me know if there's anything you're wondering about, or please feel free to reach out to me by email with any questions. And thank you so much for being here today. I really appreciate you coming to listen. Oh, great question. Thank you, Zijing, asking, does summary disregard NA values when getting summary statistics? So we talked about how mean, for example, will by default uses NARM equals false, but actually summary does, summary is a sort of special manipulation of that. It's running a bunch of different statistics at once, like the minimum, the maximum, the mean, the median, those quartiles. And for each of those, it does use NARM equals true. So it's getting those statistics for you on just the available data, and then it reports how many data are missing. Oh, and if you want to use mutate to create a new column without replacing the existing column, all you have to do is enter a different name for the new column. So when we changed sleep total, we said sleep total equals if else. But if you wanted to make it a new thing, then you could change the name to do like, sleep total recode or something equals if else. And then that would add a new variable to your data frame. Great questions. Thank you.